So yesterday we talked about angle pairs. We talked about how if they share a vertex, that you could either have a linear pair, like this angle and this angle right here, form a linear pair, or you could have vertical angles, like this angle and this angle. Those are vertical angles, as an example. But what if they don't share? Well, we said, okay, well, we could have lines that look like this, and they could be corresponding. Corresponding meant that they were on the same side of the transversal, this angle and this angle. They're on the same side of the transversal, but one is interior, in between the two lines, and one is exterior, outside of the two lines. Okay, we talked about that you could have alternate interior. So we've got alternate interior. We can have alternate. They're on alternating sides of this transversal, this vertical line right here. And they're both interior. They're both in between the two parallel lines. So we had that situation. Then we had alternate exterior. They're on alternating sides of the transversal, and they're both exterior. They're both outside of those parallel lines. And then lastly, we said, what if they're same side? We could have same side interiors. So we could have this angle and this angle be same side interior. And those two angles, they form that C, right? So what we're going to learn today is what happens when we have a relationship with the lines. So we're going to kind of discover this. So using the piece of pattern paper, copy line A and angles 1, 2, 3, and 4. So what you would do is we're just going to copy line A. So we're just going to trace it, just line A, and 1, 2, 3, and 4. And this is line A. Then it says slide the copy of line A over line B, matching up the corresponding angles. Remember, corresponding, they're in the same location. So 1 is in the upper left-hand corner, so I'm going to slide it down until it's in the upper left-hand corner of the next layer down. So 1 matches with 5. So 1 matches with 5, 2 matches with 6, 3 matches with 7, and 4 matches with 8. And what we see is that they are exactly the same size. So angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. They are congruent. So our conclusion then is that if lines are parallel, okay, these lines are parallel, that's the part that we knew. If lines are parallel, then corresponding angles have to be congruent or the same size. Okay, now if I rotate the copy of line A over line B, matching alternate interior angles. So what we want to do is take this, and I want to match up 3 with its alternate interior pair, which would be 6. So if I rotate it around and I match up 3 with 6, what I notice is that 3 and 6 are exactly the same again. 3 and 6 are the same. Not only that, look how 4 and 5 are the same. Okay, so angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. So they are congruent to each other. Our conclusion then is if lines are parallel, like A and B are, then alternate interior angles are congruent. They are the same size. So far we have that corresponding angles are congruent, and we have that alternate interior angles are congruent as long as the lines are parallel. If the lines aren't parallel, then we don't know how big the angles are. We would have to have more information. But if the lines are parallel, then we can know something about the angles. Okay, rotate the copy of line A over line B, matching alternate exterior. So we matched our interior, right? We matched 3 with 6. We rotated it around. So now let's match 1 with 8. So they are alternate exterior. So let's roll it around. And so let's match up 1 with 8. And again, what you're going to see is that 2 matches with 7 and 1 matches with 8. So angle 2 is congruent to angle 7, and angle 1 is congruent to angle 8. So our conclusion then is if lines are parallel, then alternate exterior angles are congruent or the same size. So we've seen a pattern going on here. Now, rotate the copy of line A over line B, placing same side or consecutive interior angles adjacent. Adjacent, remember, means side by side, where they share a vertex, side by side. What is their sum? So let's rotate it around. So what we want to do is we want to look at 3 and 5 together and 4 and 6 together. So if I rotate it around so that 3 and 5 will share a vertex, here's 3 right here, and here's 5 underneath the 4, okay? So notice that these two right here form this straight angle. Their angles share this vertex right here, and they form that 180. So their sum is 180 because they form a linear pair. So since they form a linear pair, then our conclusion is if lines are parallel, then same side or consecutive interior angles are supplementary. So with this picture, angle 4 plus angle 6 is equal to 180 degrees, and angle 3 plus angle 5 is equal to 180 degrees. Now if you notice, look, these look to be the same. These look to be the same. This is acute, this is obtuse, this is obtuse, this is acute. The acute angles are going to match. The obtuse angles are going to match. But if they are acute and obtuse, they're going to sum to 180. They're going to be supplementary, regardless of where they are on the page. So that's just a nice, helpful feature. We don't like to say because it looks like it, but in this case, we can't even lie about it. It's just going to have to happen that way. Now, vertical angles and linear pairs exist with or without parallel lines. It doesn't matter if the lines are parallel. Vertical angles and linear pairs always exist, period, okay? Vertical angles are always congruent, and linear pairs are always supplementary, or they add up to 180. Okay, so those are just things that always exist. Vertical angles look like this, right? Those are vertical angles. These are vertical angles. They are always congruent to each other. Linear pairs always look like something like that. They're going to form, they're adjacent, and the base, their non-adjacent sides, form opposite rays. Okay, so let's look at some problems that have to do with this. Again, like I said, you can always use if they're acute and if they match, right? So they're going to match up. I think it's sometimes helpful to have these where you can highlight them and see how they match. So you could start right up here. You might start with angle 1, 2, 3, and 4. They're all on the same vertex. That means if they're all on the same vertex, you're going to use vertical angles or you're going to use linear pair. So the first thing I like to do is start with vertical angles. Now there are lots of places that you can do, but that would be the first thing because you can just start there with your vertical angles and you can see it. Now angle 1 and angle 2. Angle 1 and angle 2 are equal to each other, but they are a linear pair. If you look, angle 1 and angle 3 are a linear pair. This angle 1 and that 98 degree angle are a linear pair. So you can take 180 minus 98, and you get that 82. So angle 1 is 82. Now, if you can, 82. That's not 82. Put it in the wrong place. Okay, so now what you want to envision is what we just did with this patty paper. And if you need to, you can grab some patty paper, you can trace it, and if it's been drawn well, then what you can do is you can just slide it down and see, oh wait, look, see how they match up. So this up here was 98 when I slide it down. That means that that angle is also. So angle 6 is 98. And then you work away around your circle from there. As long as you know one angle, so you can almost use whichever one you want, corresponding, alternate interior, alternate exterior, whichever is the most familiar to you, you can use that to get down to your next vertex. Once you're at that vertex, then you have linear pairs and vertical angles to work with. And so we can find out that all of these angles are very similar. And you're going to have a lot of that when you have a lot of angles in this picture. So angle 1 is 82. Angle 2 was 82 degrees. Angle 3 was 98 degrees. Angle 4 was 82 degrees. 5 was 98 degrees. 6 was 98. And 7 was 82 degrees. Okay, so again, you notice all your acute angles are the same size, all your linear pairs are the same size. If you look right here, here are your same side interior angles. They are supplementary. Now that same side interior angles being supplementary comes in handy when you're looking at a picture like this. You can start with angle 1 or you can start with angle 2 in this picture. It doesn't matter which one, but what I notice is that there's the vertex of angle 1, there's the vertex of that 50-degree angle, and if I connect them, that's my transversal. I notice that the 1 and the 50-degree angle are on the same side. Same side interior angle, we think same side supplementary, SSS, same side supplementary. That means that angle 1 plus the 50-degree angle is equal to 180 degrees. Those two angles are going to add up to 180 degrees. Well, if they add up to 180 degrees, then angle 1 is equal to 130 degrees. So we have 130 degrees. So angle 1 is 130 degrees. Now, here's what everybody wants to do. Then everybody wants to use that same relationship here with this 130 and this 2. But there's a problem. These two lines are not parallel. I can tell because they do not have the arrows that these two lines have. These are not parallel, so you cannot use that. So find the vertex of this angle, find the vertex of that angle, and connect them. That's the transversal that you need to use. So now we've got these angles. So look at those two. Look at that angle 2 and that 82-degree angle. They are on alternate sides of that transversal. Because they're on alternating sides, they're either alternate interior or alternate exterior. They are interior because they're between the two lines that are parallel, which means they are alternate interior angles. And our theorem says that if lines are parallel, then alternate interior angles are congruent, which means that this angle has to be 82 degrees also. Okay, so be really careful with which ones are parallel. It doesn't apply. It only applies if they're parallel. Them being congruent only works if they're parallel. Okay? So we can look here at this picture. Notice I have these two lines are parallel to each other, and I have these two lines are parallel to each other. Now, how you get back and forth between the two lines, it doesn't matter. You can start with A, you could start with E, you can start with any of them, or you could start with the other angles that aren't even labeled there, and you can start working on those. Well, I'm going to start here with A. If I use this as my transversal, right, if I connect the vertex of that 40 to the vertex of that A, that's my transversal. I notice that the 40 and the A are on alternating sides of the transversal, so they are alternate. They are interior. If I ignore everything in this picture except for those pieces, there's my 3 lines, I ignore those. So that means that A is 40. I always label it on the picture when I write it in the blank too. That way I have it and I don't have to worry about it later. So I want to work my way around the picture. There's that 40-degree angle. I'm going to slide down this 40-degree angle, and there's my next vertex. So I have now this. So now I'm looking at these two parallel lines. So now I'm looking at that picture. So notice that the 40 and the B are on alternate interior. If lines are parallel, then alternate interior angles are congruent. So that means that angle B is 40 degrees. Now, B and F are vertical. They share a vertex and they are vertical. So that vertical angle F is 40 degrees. From there, now you can keep working your way around the picture and you can do whatever you see. So from here, you could do 40 and E. Those are corresponding. If you connect down this transversal, now we've got this transversal. Okay, so B and E are on the same side of the transversal. One is interior, one is exterior, which means that they are equal to each other. They're corresponding, but this E is also alternate interior with F. So they are on alternate sides of that red line, and they are both interior between the two yellow. From there, now we're all on one vertex. You only have two options. They're congruent or they're a linear pair. So either way, you can go to either one. Then C has to be 140, so they can be a linear pair. And then D has to be 140 for the same reason, or because they're vertical. So C was 140 degrees, D was 140 degrees, and E was 40 degrees. And you could have found most of those letters in any particular order. Okay, so if we look at our picture for number 4, notice that these two have arrows. Remember, those arrows mean that they are parallel. So that's where I'm going to start with those parallel lines. Now, those parallel lines need to be connected with a transversal. So I connect those with a transversal, and then what I want to look for is I have a vertex here, and then I have a vertex here. Now, look at that 75. Look at where it is, where it's located, and then find the same location at its next spot. So 75 is right here in this corner. So it matches up with Z. Now, that is not the only place to start this problem. It's where I chose to start this problem, but that means that Z is 75. Now, another place that you could have started the problem is you could have started right here with Y. Maybe you saw that first. Maybe you saw all of these things attached to this one vertex here. Well, 60 degrees and angle 1 they're both 60 because they are vertical angles. Okay, so those are vertical angles. These are corresponding angles. And then from there, you have two choices. One, you can look at these are same side interior angles, that x plus 60 plus 75. Or you could also look at it this way, that those three angles right there form that straight angle, and they add up to 180 degrees. So I could do 60 plus 75 and get 135. Subtract that from 180, and you get, not that. Sorry, typed it in wrong. 104, you get 45. So I take 180 minus 135, and you would get 45 degrees. So this angle right here has to be 45 degrees. Now, notice I did the same thing. I added 60 and 75 and subtracted from 180. I could do the same thing right here with these same side interior angles. Okay, so here you have your linear pair or your straight angle, or you have your same side interior angles. Either way, you get that x is 45 degrees. Okay. Now we have this last one, number 5. Again, I think it's always good, as soon as you see that lines are parallel, if you will go ahead and highlight those parallel lines, and then you have to decide where you want to start. Start with your givens. I've got 72 degrees here, and I've got 46 degrees here. So I'm going to start over here with this 46 degrees. So I am going to connect that vertex to the next one up, and I'm going to keep going. That is my transversal. So I have two choices. I can start with angle 3. If you look, angle 3 and angle 46 are corresponding. So angle 3 and angle 6 are corresponding angles. So if you chose to start there, you would see that this is 46 degrees. Notice they're both acute, and so they're both 46. Now, the other thing that you might have noticed is you might have seen this first. Those are same side interior angles. So you could have taken 180 and subtracted 46 degrees. So 180 minus 46 is 134. So you could have started there and gotten that's 134. But look, either way, you could have started with this 134, and then you could have done 180 again, because these two together form a linear pair because they're on the same vertex, so they're a linear pair. Okay, you could have done that, or you could have started with your corresponding angles. So whichever one you see first, that's the one that you can do. Okay, so I'm going to make notes over here. These are same side interior. They add up to 180. So we get that angle 5 is 134. And then you get that angle 3 is 46. And again, you could have started with angle 3 and then done angle 5 with a linear pair. So it could have been a same side interior, or it could have been a linear pair. Now, if we want to go the other direction, you can still use those parallel lines, but now we need a different transversal. So this other transversal is right here. Again, everything's on the same side. So we either need to use corresponding. If they're on the same side, we either have to use corresponding or we have to use linear pairs, or we have same side interiors. So those are a couple options. So again, it's whatever you see. You could start right here with this angle 2. They are on the same vertex and they form that straight line. They are adjacent and they're supplementary. So you could take 180 minus 72 and get 108 degrees. So you get that angle 2 is 108 degrees because it's a linear pair with that 72-degree angle. Now from there, you can use 2 to get to 4 because they're corresponding. They're both underneath the line on the right side of the transversal. Or you could have gone up here to angle 1. They're above the green line on the right side of the transversal. So you could have gotten that angle 1 is 72 degrees that way. Or you could get that you have that 108, that angle 4 is 108, and then angle 1 and angle 4 are linear pairs. So you have a lot of options. Just don't forget linear pairs and vertical angles are options. And then also corresponding angles and all your others, alternate interior and stuff like that. So being familiar with those gives you some fluency and helps you to work these problems faster. So everything comes down to these statements at the front that we did, okay? If lines are parallel, corresponding angles are congruent. If the lines are parallel, alternate interior angles are congruent. If lines are parallel, alternate exterior angles are congruent. And if lines are parallel, then same side or consecutive interior angles are supplementary, or they add up to 180. Vertical angles are always congruent. Linear pairs are always supplementary. And y'all, these corresponding angles exist on parallel lines and not on parallel lines, but they're only congruent if the lines are parallel. So all of these things that we talked about today only exist if the lines are parallel.